Hi guys, we'll get started in a minute. Waiting for everybody to get here. Now this should be interesting. Let's see if we can do this. I think I'm going to be using the projector today. So I'll maneuver the screen around once, the camera around, once I get the stuff projected. So just bear with me a second while I get myself set up here. So chapter 5. Would you guys mind if I close the door? I'll clean up my spot too. I'm telling you. I'm telling you. All right. So I think I'll do some notes up on the board, and then I think I might have suggested you bring your scientific calculator with you if you have it. If you don't have one, you don't have to buy one. One like Melissa has there.
Right, I use that for.
I'm sorry?
I use one of those for.
Yes. Yes. So if you have one of those great TI-83, TI-84, know what you have?
Yeah.
Yeah. This is a great calculator to be able to use. Okay, you guys can see my board there a little bit. Okay, so just yell out if you don't have it, if you can't see it that well, but this is what I'm talking about, one of these calculators. Okay, we'll be utilizing that a lot in class. Now, the good news is I learned this back in 1987 and 1988, way before we had one of these fancy Nancy calculators. So there is always a method. So people will download apps. There's finance apps that you for free. So if you don't have one of these calculators, they cost over $100. So you don't have to go and buy one. You could actually use a finance app on your phone. Or you could use formulas for the stuff we're going to do, or there's tables even. So we got lots of methods of and workarounds to help us get answers to the stuff we're going to be looking at. I lost my straw. All right. So what are we going to be looking at? Well, chapter 5 is really a finance chapter. So this is all calculations, but these are special calculations we use quite a bit in accounting. So we introduce them to you now. If you take, well, you have to take finance basically, or math of finance. And if you take one, and if you take those classes, you'll revisit these concepts we're going to talk about, and you'll see them throughout the rest of intermediate accounting. So simply put, what the chapter is called is time value of money. Okay. So here we go. So if you guys at home can't really see this, let me know. I'll try to adjust the camera there. Time value of money. You guys okay? Yes, I can see it on the screen. Okay. So time value of money has to do with $1 today is worth more dollar-wise in the future. A dollar today is worth dollar-wise more in the future. So a dollar in the future is worth less than a dollar today. Why is that? There is always an earnings associated with money. There's always some type of earnings, or we could say there's interest. So today, $1, if you want to know what it's worth in the future, using some interest rate, you can calculate that. So another thing we always keep in mind is money is always earning, always earning. And if it isn't, it should be. Okay, so that's like an unspoken rule for this chapter. Like, I remember learning this going, well, what if you don't want to earn money? Well, then this calculation doesn't need to be done. Okay, just put it in your mattress and there's your dollar. But that dollar will purchase less in the future than it could purchase today. And I always talk about way back in like 1977. I was like 9, 10 years old back then. And I used to go to the store for my mom and get bread. It was like the corner store, but I lived in Brookside. So our corner store was in the middle of the street. So I kid them. It's a joke. But anyway, like we were kind of backwards. So we always had, stuff a little bit different. But anyway, I would go up to the store and I would have 45 cents, 50 cents really, to buy a loaf of Sunbeam Ranch bread, king size. You guys know what I'm talking about? 45 cents it cost in 1977. I remember that. And I remember it went up. I used to like going because I'd have 5 cents left over to get some penny candy. Like I get the little wax things with the juice in them and stuff. Do you guys know what I'm talking about? Nah, yeah. That's it. They were like wax sticks, and they would have like, some kind of sugary stuff in it, and it was just good. But we would be able to get some candy, so I always went for the bread. Well, the one time I went with the 50 cents and the bread cost 50 cents. And I remember, this must have been me going, someday I'm going to do something with money, because I went, someday this is going to be $1. In my 10-year-old brain, I went, someday this will be $1. Now it's $3.50. Okay, so in 1977, you could buy a loaf of bread for less than $1, less than 50 cents. Now look at it. So if I kept that 50 cents and never invested it, never earned money on it, I wouldn't even be able to buy 3 pieces of that bread today. And that's what we're talking about here. Money should always be invested in earning. We cool with that? All right. Okay, so with that in mind, we need to make sure we understand. There's 2 types of interest calculations. The one we have done for the most part in accounting, and it's called simple interest. Simple interest. And we did it because it's simple, right? It was very easy to introduce you to interest and calculations related to interest, because it's pretty straightforward. And the rule is take the principal only times your interest rate times time. And that gives you your interest. Now, something else that's really important to remember in this class is whenever you see an interest rate, it always is an annual interest rate. always, sorry. Give me 1 second. So it's always an annual interest rate. So if they're saying you have to calculate interest only for 6 months, we really need to worry about this time factor so we calculate interest correctly. But watch what happens with a simple interest calculation. Let's say you have, you invest, so you put money through $1,000 today that will earn interest at 6% per year. How much interest will accumulate in 3 years? So how much interest will this investment earn in 3 years using a simple interest calculation? So if we take the calculation as we see it here, interest equals $1,000 principal times your interest rate, 6% per year, times time, 3 years. So the interest will be $180 if it's simple interest, because we only calculate interest on the principal. And it's pretty simple, right? Pretty straightforward. But that's not how the world works. Okay? 99% of our investments do not just calculate interest on the amount of money we originally invest. Instead, it uses compound interest. And that's really the focus of this chapter. Compound interest. When you calculate compound interest, similar formula, but you will take the principal plus all interest earned as the first number. So it's just not the principal, but all the interest that you've accumulated, maybe that's a better word, all interest accumulated that's still in the investment. Now times it by the interest rate. And then by time, which we are going to really define for you, interest rate and time. When you are calculating interest more than once a year. We're going to keep this calculation to an annual calculation. But here's what happens in compounding. We need to define, or it will say, we are going to compound interest annually. What that means is they're going to calculate interest annually, once a year. This is what happens with compounding. I'm going to set up a little table here. So this will be my date, my computation, and my new balance. So I only needed 3 columns. Let me delete that last column there, so we got lots of room. And I'll move this so you guys can see it. So now we're going to change this so that we are going to invest $1,000 today that will earn interest compounded annually at 6% per year. So now this is our situation. So today is October 26th of 2020. Today's the day we put $1,000 into our account. Let's see what it'll accumulate to in 1 year. So at 10/26/2021, use your formula that's up above. The principal right here plus all interest accumulated. Well, there is no interest yet. So it'll just be the 1,000 times the annual interest rate, which is our compounding rate, since we only compound once a year, 6%, times 1 year. So that will give us $60. So that's kind of like the simple interest computation because you're just using the principal. But this changes all future calculations. Assuming we leave the interest right where it's at, our new balance in this account will be $1,060. That's important because when we calculate interest for the end of year 2, we don't use the $1,000 principal only. We use the 1,000 plus the interest, the new balance of 1,060 times 6% times 1 year. I need my calculator. $63.60. So notice, we're not just calculating interest on the original principal, but also in the second year, we're calculating interest on the interest from last year. That's what compounding is. So now our new balance will be $1,123.60. Add that interest in. Going into year 3, our last year, how much interest will we calculate? Under compounding, take the new balance of $1,123.60 times 6% times 1 year. And I get $67, I'm going to round it, and 42 cents. So now, at the end of the third year, 1123.6 plus that new interest of 67.42. Whoa. The balance in the account is $1,191.82. If that's our total balance, and 1,000 of it was from our original investment, we earn $191.82 over 3 years using compounding. You only earn 180 under simple because you're only computing interest on the original principal under simple. Under compounding, you're computing not only interest on the original principal, but previous year's interest that are still in that account. That's what compounding is. Are there any questions on it? And that's how the world works. You know yourself, you put money in your savings account, it earns interest. The next year they don't go, oh, you only put $1,000 in originally. No, they say, what's your new balance? And that's what we're going to compute interest on. That's what compounding is about. So this is great for us to do in this cute little table, right? 3 periods, who cares? What if you needed to know what this 1,000 would accumulate in 20 years? We're gonna sit here doing this table all day long, driving ourselves a little crazy? No, we have shortcuts. And this table or this chapter introduces you to some of the shortcuts. But before we start showing you those, let's make sure we understand some things. There's 4 very important variables for them, and you need to know at least 3 of them to do these computations. The first one, we use the abbreviation PV, and that means present value. And that is essentially your value at what we call time 0 or today. So our present value is today, 10/26 of 2020. So in our problem, that's our time 0 value. The day you make that investment, today, $1,000. So that's the value of this, the very first day. The next thing you may know, you may know present value, you may need to compute it, is future value, FV. Future value is the value of the present value at some point in time in the future. And you have to define that. So what is that $1,000 going to be worth at the end of 3 years if we compound it annually at 6%? So there's the future value of our little problem, $1,191.82. So we calculated that on our table. You need a compounding interest rate. And here's how you determine that. It's your annual interest rate divided by the number of times you compound during a year. So all compounding means is that you're recalculating the interest. You could recalculate interest more than once a year. We just showed it once a year. And we'll show you how we change these interest rates according to the number of times you actually compound during a year. The final thing you need is your number of periods. And number of periods is not number of years. So it's the number of compounding periods is how we look at this. And it will be the number of years times the number of times you compound during a year. So the number of periods, the number of years times the number of compounding, number of times you compound during a year. That will equal your N, or number of periods. Sorry, I should have given you the little abbreviation there. We'll use IR to represent interest rate, and N equals the number of periods. So in our example, the number of compounding periods was 3 years times once a year, because it compounds annually, or 3. And the interest rate was 6% divided by 1 because it compounds once a year, 6%. So once we have 3 of these 4 items, we can calculate the 4th. Now, let's get into the different types of calculations. Any questions? So I'm going to do it through examples. So let's say our first example, John wants to, John has $10,000 to deposit in his savings account today. How much will it accumulate to in 20 years, assuming an 8% interest rate? Now, if it doesn't say it, the assumption is it compounds annually. So if it compounds more than once a year, it will state it in the problem. So if it doesn't state anything about compounding, the assumption is it happens once a year. Remember, compounding only means we recompute interest. This happens once a year for this type of deposit. Now, some people say, well, I'll just create a little Excel spreadsheet and put some formulas in. And why? Why do that? They're shortcuts. So let's take a look at the shortcuts. The first shortcut is in the very back of your book, and they're tables. They start on page P1. Wait, it's like the last thing in your book. Very, very last item. All the way in the back. If you brought your whole book.
Oh, yeah.
I'm talking, it's not at the end of your chapter, it's all the way at the end of your book. So that's okay. You'll like your calculator better. But I like showing you a couple different ways because then you could always check yourself. You know, even way back when I was able to check myself to make sure I was calculating stuff correctly. Okay, so in your book, and I'll give you this formula too, there is something called Table 1, Future Value of 1. So let's see which of these items up above we know. Do we know the present value? Yes, the present value of this investment is today's amount, 10,000. So I'm going to jot that down. Do we know the future value? No, that's what we want to calculate. So I'm going to put a little question mark there. Do we know our compounding interest rate? Excuse me?
We have to find
Just the interest rate itself.
yeah.
Yeah, it's there, 8%. We compound once a year, 8% divided by 1, 8%. Do we know the number of periods we're going to compound this for or calculate interest? Yeah, 20 years times once a year, so 20. So we have 3 of the 4 variables. When we're trying to figure out the future value, one thing you can do is use this table at the end of your book. What this table represents is what $1 is worth under different circumstances. So across the top here, I'll pull this up on the, let me just grab it in what's that called? Connect. But across the top are different interest rates. So you got to kind of hope that your interest rate is there. So columns are interest rates, rows are periods. Okay, so here is this first table I was just talking about. So columns, there's different interest rates. Now our interest rate, why isn't it going across? There it goes. So we want to be back up here for the future value of one table. There's 4 or 5 different 6 tables. So we're trying to figure out future value. What this is saying is, well, here's the future value of $1. If your interest rate is 6%, you would use the 6% column and then go down the number of rows for the number of periods. Well, let me see if I can get to that 8% column. Oh, there we go. Each one has their own little thing. So there's the 8%. Then I'm going to go down 20 rows. And usually you can see it over here on the side. It disappears, but 1, 2, 3, 4, 5, 6. And this 20, it should be at, just trust me on this. There's the 8%. 4.66096. So what that's saying is $1 invested at 8% compounded annually for 20 years will accumulate to $4.67 in 20 years. That's what it's going to be worth, its future value. But we're not investing $1 here. We're investing $10,000. So it says, well, just take what $1's worth according to those conditions and multiply it by how much you're actually investing. So I call this the factor. This is a factor. So I'm going to go back. 4.66096. Where's my word? There it is. And what I do is the future value equals the present value times the table 1 factor using 8% for 20 periods, which is the 4.66096. So 10,000 times 4.66096 will give me $10,000 times 4.66096 $46,610. I'm just going to round that. Instead of doing a table where we keep computing the interest on the interest and computing, we could just use this table because it already tells us what $1 invested at 8% for 20 periods is worth. So if we know what $1's worth, multiply it by what we are actually investing. Now, how did they get this 4.66096? A formula. And the formula is at the top of the page. So if you're into algebra, if you're into math, right? Future value can very easily be calculated using a formula. So what if your interest rate wasn't even in this table? Right? Well, future value is calculated by taking your present value. In this case, they say it's just $1 times 1 plus your interest rate, your compounding interest rate, to the, n power. or number of periods power. So you got to do that exponent calculation. But if you're doing stuff like statistics and algebra, you guys are still into math. Like somebody 35 years out, I'm like, YouTube. I don't know how to use it on my calculator. I know what I'm supposed to do, but I'm not going to keep adding 1 plus the interest rate times 1 plus the interest rate times 1 plus the interest rate. I want to get there fast. Unlike you guys, you know, if we could get there quicker, we want to do it. So what we did here was take 1 plus the interest rate, so 1 plus 0.08. And if you know how to use your calculator to do the exponents, it's a little carrot top, I call it, to the 20th power. And that's your answer, 4.660957,144. But that's how this table was created, using that formula. So this was me in the old days, this and the table. Another way, you got your fancy wancy scientific calculator here, or your app. On your calculator, now mine is in the second column, third button down. I have a blue apps, APPS button. So maybe in a different location on yours. Now find your apps, hit it. You're going to get a menu of items, applications, finance, maybe CBL, CBR, problem sim. You want to select finance. So hit mine's 1. And then you're going to get more stuff. We just want to go right to the first option. TVM, time value of money, solver. And then you have all of those neato things we just talked about, those variables listed. Now there's more stuff there that we're going to hit on more on Wednesday. We're just going to talk about the variables that you need to fill in here. But make your end the number of periods. So your cursor should be flashing there. So 20. Now, when you're maneuvering around, use these big arrow keys on here. You can see mine. Yeah, big arrow keys. I'm going to hit one down. I put in as a whole number. So 8, not 0.08. It translates that to a percentage. PV, you know your PV, 10,000. Now, if you have something called PMT, just make sure it's 0. We don't use that for this calculation. Nope. Use your arrow, make sure your cursor is flashing where it says FV. Now, you can't just hit enter. You have to solve. And when I look at my enter key, it says solve above it in green. So that means I have to hit my green button and then enter. Did it work?
This one?
Yes. It's alpha. Mine says alpha on it. Did it work for you?
Yeah.
Guys at home okay? Anybody have any questions? So if you're like, well, wait a second. This is a negative number on here. What does that mean? I have negative cash? No. Finance calculators were designed by finance people. And the assumption is the $10,000 is positive coming in. So at the end, it's going out. So that negative is representing money leaving. It's not representing negative money. Does that make sense? So it's just the way the program is designed that one number will always be positive, either present or future value, and so the other one will be negative. And that's how Excel is designed too. So if you're in your Excel classes now, or if you took Excel, you have finance functions, and you probably, did anybody take Excel yet? Did you take it? Did you do anything with financial formulas? Okay, so we have these same exact formulas in Excel. So if you go into the finance formulas, let me just show you really quick. Not that I expect you to use Excel, to do it, but what great practice. So I'm in Excel. I'll come to make it so you guys at home could see it. So I'm just going to go up into my formulas, select financial, and then look for future value. And you get a dialog box and everything. So they want to know your rate. I can't remember. Well, I'm just going to use 8 and see what happens. I think I have to put 0.08. I just, come on, you know, it doesn't give me guidance and I can't remember. Was it 0.08? Then they want to know the number of periods. I don't know if you can see, it says NPER. That's the number of compounding periods. So that'll be 20. PMT, we ignore that. You don't have to put a 0 or anything, just put another comma. And then present value, 10,000. Whoops, don't put a comma there because it'll read it as part of the formula. I think then you put a comma, close it, and there's your answer. So you got all these different ways. What's that? 4 different ways of doing a calculation. So you pick the one you like. Use a formula, and you'll have the formula in front of you in a test. Table, if you can find it quick on the table, use your financial calculator or use Excel. Or use a combination of them to make sure your calculation is correct. Are there any questions on that? All right, well, let's do another one, but this time, let's look for a different variable. John wants to accumulate $100,000 in 15 years. He can invest in an account that will pay 10% interest annually. How much does he need to invest today to reach his goal? So John wants to accumulate $100,000 in 15 years. He can only make one investment today. So he can invest in an account that will pay 10% interest annually. How much does he need to invest today, one-time deposit, to reach that $100,000 goal? So let's see what we have here. In this scenario, PV, do we know the present value in this problem? No, that's what we're trying to figure out. Do we know the future value? Yes, the $100,000, that's where he needs to end up. The interest rate, 10% divided by 1 because it is only compounded once a year. We're going to get up a notch or two in a second. Compound it more than once a year. And then N will be 15 years times once a year for the compounding, so 15. All right. So one way of calculating this is go to those tables in the back of your book. Flip the page. Table 2. In table 2, the author here went and made tables of how much $1 in the future is worth today. given an interest rate and the number of periods. So what it's saying is, let's say you accumulated $1 at the end of 20 years that earned an 8% interest rate. So I could use my 8% column, go down 20 periods. What did I originally invest to get that $1 in the future? 21,455 cents. That's the present value. That's how much you would have invested to reach that $1 in 20 years at 8%. You follow me on that?
I did it here and I got 23.
But that's not, we're not, for this?
Yeah.
Oh yeah, that's not what, I'm just talking about the table here.
Oh, this is it.
Okay, so let's take a look at this. This is a sorry, did you have a question? Oh, okay. This is a 10% interest rate, so go to the 10% column. 15 years. So I'm gonna go down 15 rows because the N is the rows. So if $1 was the future value, we would have had to invest 23,939 cents. So if we multiply that by 100,000, so PV would equal the future value times the table 2 factor, 10% interest for 5 period, or 15, I keep saying 5, 15 periods. So PV equals 100,000 times 10%, 15 periods, 0.23939. So now this is probably your answer there, Penelope. What should he have invested? $23,939.
It's easier in the calculator.
Yes, it is easier in the calculator.
Yeah,
But not everybody has that calculator either, right? So that's the quick, use that factor, given 10%, 15 periods, I have a factor that I can multiply my future value by to get what I need to invest. How did they get this 0.23939? Well, let me show you. The formula is at the top of the, it's at the top of the table that says, take your present value, your future value, and divide that by 1 plus your interest rate to the number of periods power. So we take the $1, which is the future value for this table, divided by that result. So 1 plus 1.10, 1 plus 10% would be 1.10 to the 15th power. That will give you 4.177248. Now divide that into 1. So 1 divided by 4.177248169.23939. And it keeps going on with other numbers, but we cut it off after 5 decimal places. So you can use the formula, take your future value and divide it by 1 plus the interest rate raised to the 15th power, and it will also give you $23,939. So that's method 2. Then we got our finance calculator, which I think you guys have just bypassed everything I just did here and went right to your calculators, but that's okay. You'll put me on your zombie apocalypse team to know the formulas, right? Okay. Finance, I'm in my finance calculator, time value of money solver. Now make sure your N is 15, your I is 10, You're solving for present value. So make that a 0 for now. Use your arrow keys to go down and put your future value in because you know that. Then use your arrow keys to go back up. Cursor should be highlighted over PV and alpha enter. 23,939. You know what I love? Like when these things first came out, half the battle in this class was teaching everybody how to use these calculators. Now you're like pros on them and I love it. You know, you're like, yeah, okay, I got that. I'd be getting, where's there an apps button? Huh? And then I have somebody like 70 in my class going, what kind of calculator do we need? I'm like, just use the formula. I like formulas, okay. But if anybody's having any issues with the calculator, let me know. But I think you guys have are pretty much pros on this. Again, my present value is coming out as negative because I put my future value in as positive. And it's just because of the way these calculators are programmed. They used to drive me crazy because I'm like, why is that doing that? And I never really looked it up. And then one day I was on the treadmill in the morning and don't ask me why, I had channel 44 on and they were explaining the finance calculator. And they explained that is why the positive and negative occurs. It's just the programming of it. Well, since we're doing this, let's take a flyover to Excel and I could show you that there is this type of calculation in my formulas, finance, PD, present value. And there it says returns the present value of an investment or the total amount that a series of future payments is worth now. So our rate, 10%. NPER is the number of periods, and it even explains what each one of these is worth, or represents, I should say, not worth. Payment is still going to be 0. We'll talk about that on Wednesday, and then we can put our future value in and hit OK, and there it is. That's probably my favorite. You know, once you get used to using formulas in Excel, whew, takes you no time at all. Any questions? All right, then, let's have some real fun. This is when you'll really appreciate your calculators. John wants to accumulate $50,000 in 10 years. He has $35,000 to invest today. What interest rate must he earn to achieve his goal? Okay, what interest rate must he earn? Kind of, investment interest rate to achieve his goal. Now, I don't really use the formulas for these. Those of you who understand natural logs and all that crazy stuff with exponents, and they have some great videos out on YouTube that if you wanted to use the formula to solve these, you can. This is probably best in your financial calculator just because I created it and I don't know what the answer is. Okay. But usually in your book, when they're asking you for an interest rate, there will be a pure answer, or I'll show you what we need. So what do we know here? Well, we know the present value. 35,000, right? That's how much he can invest today. Future value? 50,000, what he needs it to accumulate to. Interest rate? No, we need to solve for that. We know the end? 10 years, right? So 10 periods, because the assumption is it compounds annually. Now, if you're using the tables to do this calculation, here's what you do. Well, what you can do, and this is where you would have to start using natural logs and weird calculations. You could fit what you know into your formula up above here, and solve for interest rate. You can do this. If you use present value as your numerator, okay? So you divide present value by future value. You will use the present value table to determine the interest rate. Your answer is not the interest rate. You will use the table. So that means if I take 35,000 present value divided by 50,000, that's going to give me 70.7. That is not my interest rate, not 70%. What is that? That is the factor you must find in the 10-year or 10-period row to determine the interest rate. And I'll pull up the present value table and show you what we're talking about here. But you could take present value divided by future value. This tells you a factor you have to find on your table. Since you know the number of periods, you can use that row on the table. So here is my present value table. I'm going to go down 10 rows. And I'm going to start going across. And here is where I hit 0.7. Or was it 15 years? I forget. 10 years? Okay. So this says I need to earn at least. So this is going to be off just a little bit. But the table says, okay, here's row 10, 0.7, 0.7, 0.7. 0.0892, pretty close. 3.5% interest. What is it? 3.5%. Now, if I use my calculator, I could go to my apps, finance, TBM solver. Now be careful. N is 10. Make sure your I is 0 while you populate the rest. Either your present value or your future value must be put in as a negative number. When you put it in as a negative number, you use the little negative sign in parentheses at the bottom of your number pad. Right there. Yeah. So I'm going to put my present value in as negative. And then I'm going to go down and put my future value in as positive. And then I'm going to bring my arrows, my cursor back up using my arrow keys, and then solve for interest rate. Pretty close. 3.63 is the correct exact answer. So on a test, I'm not assuming everybody has one of these calculators. So your problems on your test will give you an exact factor that's in the table. But you see how we use that. Now, I'm trying to think. So if we take, I think I have to take a natural log, and I have to look it up exactly how to manipulate the formula there. I'll bring it in for Wednesday's class, but how to manipulate this formula to solve for I. Okay. There is a way, but I just can't remember off the top of my head. Excel. You can even do it there. Formulas. I think it's probably. It's just the rate. There it is. Rate. It's not internal rate of return. It's just rate. It would be NPER 10. Payment is nothing because we don't have anything with payment yet. You'll understand more on Wednesday. 35,000, and just like with our calculator, let's put the other one in as negative, the future value, enter. Now that is a whole number because I didn't ask for it to be more, but you can see there is my answer. So you can solve for interest rate if you need to. Questions?
When you write, the one, it can be any number in negative between the PV and FV.
It doesn't matter which one, just as long as one of them, just so that, because if not, you're gonna get an error message. Because the software doesn't understand the two positives. One has to be negative. Doesn't matter which one. Okay. John wants to accumulate $70,000. He has $20,000 to invest today. And can invest where he will earn 10%. How long until John reaches his goal? So how many periods does he need to invest his money to go from 20,000 to 70,000, assuming a 10% interest rate? So again, look to see what variables you know. Do you know present value? 20,000. Future value? 70,000. Interest rate? 10%. So it's the N we're looking for. How many periods? And guys, sometimes I interchangeably use small n and capital N. It's not on purpose. It's just whatever I hit. So don't think that they're different. So I could do the same type of calculation. Take the present value divided by the future value, but that's going to give me my factor I need to find on my table, my present value table. 20,000 divided by 70,000 gives me 0.2857142,857. Obviously a very long number. Since I know my interest rate, go back over here to my table, I know it's a 10% interest rate. This is going to be funky. Find your 10% column and go down it until you find something along the lines of 0.2857. Ooh, look at that right there. 0.28584. That is the 10% column, and it looks to be in the 11th row. So according to my table, N equals 11. You could use your finance calculator though, just to double check. 1, okay, N we're looking for, so I'm going to leave that as 0. I is 10. PV will be -20 or positive, however you want to put. Future value is 70. And then I'm going to go back up and solve. Alpha, solve. Whoa.
I got 13.
Did I put something wrong? Let's see. Oh, was I in the wrong column? I was. I'm sorry. I was in the 11% column. So 0.28, yeah, it's somewhere between. There's 10, 11, 12, 13. Let me do that again. So this answer, 20,000 is 0.2857142. I'm going to go to my table in my book. 10%. Oh, yeah. Okay. 13 at 10% is 0.289. Yeah, 66. So it is 13 periods according to the table, because that's the closest. But if you do it exact using your finance calculator, was it 13.61?
13.1.
Okay. Using your finance calculator, it came out to be 13.14 periods. So again, problems in the book will pretty much be exact. Okay, or problems on your test. You'll be able to find that exact factor in the table. But you can use your finance calculator as well. And of course, we might as well round it out here. And you can also use NPER. There it is, NPER. So your rate would be 10%. Present value, 20,000. Future value, 70,000. Enter, and there it is again. 13.14406. So that's your exact number. So we saw how to solve for future value, present value, interest rate, and number of periods. Now, what's very important to remember is the calculations we're doing today, you're making one deposit at the beginning, and you're taking out one amount at the end. There's nothing happening in between those two times except interest. Okay, we're going to change that on Wednesday, but I want to do something else before we leave today. I want to start compounding more than once a year. So now, watch what happens. John has $10,000 he will invest today to earn 10% compounded semi-annually for 15 years. What is the value of the investment at the end of 15 years? So he has $10,000 today. He wants to invest. He's going to put it in a vehicle, an investment vehicle that earns 10% interest compounded twice a year for 15 years. So what will that amount accumulate to at the end of 15 years? So see if you could do this one. Give you a few minutes. You try it. Now remember what I said about compounding. Because now we're not compounding just once a year or calculating interest once a year. We're calculating it more than once a year, twice a year. Take a look. Remember, approach it like we have. Present value, do we know the amount? No, 10,000. So that's how much the investment is today, times 0. Future value? That's what we're trying to calculate here. Interest rate, 5%, good. You take the annual rate divided by the number of compounding periods each year. So the amount of interest, the interest rate you'll use to compound for the first 6 months is 5%. When I say compound, I mean compute interest. How about the end? 30, 15 years times twice a year. So the number of compounding periods, the end is 30. That's the only difference, was calculating those two. So you can use your future value table, which was table 1, because that's what you're calculating. Go to the 5% column, go down 30 rows. And our factor for 5%, 30 periods, is 4.32194. So how much money will John here accumulate if the interest is calculated twice a year on the balance? How much will his investment accumulate to? $43,219.40. The hard part is getting those I's and N's correctly. So you can do your calculation, apps. Whoa. That's not right. Apps, finance, time value of money. N would be 30 now. I is 5. Present value is 10,000. And then go down and solve for future value. 43,219. It's off maybe 2 or 3 cents because it's a more exact number than the formulas or the factors in the book. Okay, one more. So we're going to do the opposite. John wants to accumulate $50,000 in 5 years. What is his initial investment if the account earns 12% interest, here we go, compounded quarterly, so every 3 months? How much will he have to invest at time 0? Under the interest is compounding quarterly now instead of semi-annually.
Which time of year?
4 times a year, quarterly, every 3 months. So see if you can get that. Were you right on yours, Alyssa?
Yeah.
Okay, good. And once you get your interest rate and your number of periods, then you could solve for your unknown. Let's take a look. Present value, we know it?
No.
That's what we gotta solve for. Future value is what we want to accumulate to, 50,000. Interest rate, how much? 3%. 12% annual rate divided by 4 times compounded annually. So each compounding period will use 3% interest to calculate the interest. How many times do we compound interest? 20. 5 years times 4 times a year equals 20. So N is 20. So I need to calculate present value. So you could use your table, present value of 1, table 2, use the 3% interest column down 20 periods. I'm getting a factor of 0.55368 times $50,000 will give me, $27,684. And you use your finance calculator, you might get a more exact. You use your apps, finance, time value of money, N is 20 now, I is 3. Future value is 50,000, and then I'll solve for present value. 27,683.78. I'm getting.
You round it.
You can round it, it's not a big deal. It's more about the method that you understand how to calculate it than getting the exact number, you know? Okay, so I want to get through that. So whenever you have compounding more than once a year, you've got to be very careful to change the interest rate from an annual rate to the number of interest rate per compound period during that year, and then change the total number of compounding periods. Okay? So Wednesday when we come in, so you get practicing in chapter 5. We're probably going to wrap up chapter 5 actually on Wednesday. We're then going to talk about annuity calculations, which are a little bit different. Here, you're going to calculate the present value and future value, assuming there's more than one deposit being made. Little sneak preview. This is how we determine the lump sum payout when you win the lottery. Now they say it's a $70 million lottery, but the lump sum payout may be 15 million. Well, present value and future value is how they calculate that. So we'll show you that. Okie doke. All right, guys, I'll see you on Wednesday. I think we're back to being live. I think everybody's back in the classroom as of Wednesday. So if you're not going to be, if you're still under quarantine, just drop me an email just to remind me, and then I'll see who I still need to make a live video for. But if not, you guys on Wednesday. Have a good one.